Greetings, coders. In this video, we're going to look at how global and local variables are stored in memory while an ELF binary is executing. So what is a binary? Well, a binary is the result of compiling our source code. And we end up with this main.bin in this case. It can be any name. It doesn't require it to have the extension .bin. That's just something I do to make it easier for you all to recognize it when you're working with it. We can run this file command on it, which will give us information about the file, and we can see that it was compiled into a 64-bit version and that it is in x86-64 architecture, which means that the instructions the source code is compiled into will work on that architecture. ELF is the format of the binary file, and it stands for execution and linking format. So what is an ELF? It is, as I said, the binary format, and it is comprised of several different sections, and here's a subset of some of the important ones. The first one is the text section. In this one, that's where all the compiled instructions are included. Then we have the BSS and data sections. They contain the global variables. Which section they're in depends on whether or not they were initialized in the code. The init section helps load the program, get everything in order for the program to execute, and then hands it off to the actual program to run. The linking sections, there's several of them, are metadata used to describe the components of the program that are going to be used. For example, if you included stdio.h, then that would be in the linking section for whatever functions that you used would be linked out to where that exists in the library out in the operating system. And then last, we have the debug section. So when the -G option is used with GCC, a bunch of additional information is included in the debugging section. So in general, when your program runs, the overall memory layout looks something like this. It has the command line arguments, which are really part of the stack as well, but we've separated out here. And then it has the stack. It has the heap that we'll talk about later. And then it has global variables and the executable code. So the local variables, when you create a local variable, no matter which function you create it in, it goes on the stack. Now in memory, this looks something like this. We have the command line args up here, and then you have memory for the stack as it grows and contracts. The heap can grow considerably. It's a very large area of memory it's allowed to occupy. So it starts at a much lower number. You can see the big change here. And then just below the heap, we have the data area with the globals. And then we have the executable code just below that. Now we can look at what happens when we execute this program. The global int is stored down in the global area. So it has an address of 58008. And then the local int is stored up here at dd008. We have the global int at 800, starting with a 5, and the local int starting with a 7, ending with an 08. So now let's look at what happens when we define a bunch of local variables. With each new variable, they go up the stack. So the stack grows upwards, similar to how the heap grows as it increases. So this is the bottom of the stack. And if you've ever, for example, run into a recursion problem where it says you ran out of stack, this is what happened even in Java. You executed and the stack is limited, much more limited in size than the heap. And so it runs out of space more quickly. Each new function call, there is additional stack space that's used. So if we start here with I0, I0 comes down and it's set there. And then with the next variable, it keeps getting pushed onto the stack with each new value. They go up the stack. And so at the end, we have the last value that is stored up here. And then as we work through the program, this is where the program will access and use those local variable values. And that's it for this video.